Hello guys, welcome to our YouTube channel Engineers World. This is second lecture of engineering mathematics. In this lecture we will solve some previous year questions about the inverse of a matrix. Okay, let's start. So first question here is, let A be an invertible matrix and suppose that the inverse of 7 times A is given to us. That is, question is saying that we have any matrix A whose inverse is possible. That is, inverse is defined. We know inverse is not defined if the determinant of a matrix is equal to 0, because inverse of any matrix A is equal to 1 by determinant of matrix into adjoint of a matrix. Okay, so if a matrix is a singular matrix, that is, the determinant is 0, so inverse of matrix is not possible in that case. So here it is saying that inverse A is an invertible matrix, that is, inverse is possible for this matrix, and we have given the inverse of 7 times A. A we have to find, but in the question it is given that 7 times of A matrix inverse is equal to -1, 2, 4, -7. So from this we have to find the matrix A. Okay, so options for this question were, first option was 1, 2 by 7, 4 by 7, 1 by 7. Okay, option B 7, 2, 4, 1. Option C 7, 4, 2, 1. Okay, so these are the options for this question. So it is saying that inverse of 7 times A matrix is given to us. So from the options we are going to solve this question, so that we are assuming that for take option A first. Okay, we are assuming that our matrix is equal to, that is, A matrix is equal to 1, 2 by 7, 4 by 7, 1 by 7. That is option A. So from this we are going to calculate 7 times of A of matrix. That will be 7, 2, 4, 1. Okay, now calculating the inverse of this matrix. So here first I am going to tell you the shortcut for calculating the inverse of a 2 cross 2 matrix. That is, if we have any matrix A is equal to A, B, C and D, to calculate the inverse of this 2 cross 2 matrix, there is one shortcut, that is 1. We know the inverse of matrix is 1 by determinant of a matrix into adjoint of a matrix. So determinant is, we know how to calculate determinant of this matrix, that is A in AD minus BC. And to calculate the adjoint is simple, just interchange the position of leading diagonal elements, that is D, A, and change the sign of non leading diagonal element, that is this diagonal elements. Okay, these B and C, change the sign. Okay, so 1 by AD minus BC into D minus B minus C A. So from this will be inverse. 7 times the inverse will be 7 into 1 is 7, minus 4 into 2, that's 8. So determinant will be -1. This 7 minus 2 minus 4. Okay, so taking minus inside, it will -1 plus 2 plus 4 minus 7. So that is, so 7 times the inverse is this, and these two are matching. Okay, so our answer for this question is option A. If these two are not matching, we will proceed to the option B. Since these are matching, so no need to proceed option B. Okay, so this was the question first, which was asked in the GATE. So second question was, if A is in the matrix this, that is 0 1 0 0 0 1 1 0 0, we have to find the inverse of this matrix. Okay, so we know the basic definition of calculating the inverse is 1 by determinant of matrix into adjoint. So first calculate the determinant of matrix. Determinant we are solving from row 1, so this will give the 0. We know this will pass to minus positive. Okay, so minus 1, and hiding this column and this row, 0 1 1 0 plus 0. So after solving this, we will get minus 1 inside minus 1, that is equal to plus 1. So determinant of this is equal to 1. Now calculating the adjoint of a matrix. We know the adjoint of a matrix is equal to transpose of a cofactor matrix. So calculating the transpose of first calculating the cofactor matrix. Let us denote that by C of A, that is cofactor of A. Cofactor is simply, we are going to, for this element, hide this this row and this column and just solve this. So first element 0 and this one, and with sign also. For cofactor we have to take the sign positive negative also, and for minor, so sign is not there. So for this one, hide this row, this column, and this row, will get 0 and minus 1. So and minus 1 from the basic sign for this, that is positive and negative, positive, negative, positive, negative. Okay, so minus 1 and minus 1 from this, so it is plus 1. Okay, for this element, that is hide this row, and this column, that is we are getting 0 also. Same for this element, this one and this one, 0 and 0 0. For this one it will be 0 and minus 1, and minus 1 from the hiding this 0, minus 1 and minus 1. Okay, plus 1. For this one it will be 1 0. Okay, 1. These two will be simply 0. Now taking the adjoint of this will be, adjoint of A will be just transpose of this, that will be 0 0 1 1 0 0 0 1 0. Okay, and we know inverse of A will be just divide adjoint by determinant of matrix. So this is 1, there will be no change, so it will be 0 0 1 1 0 0 1 0. Okay, the same, sorry for this, 0 1. Okay, so this was also asked in the gate. Okay, it's easy, just we know the how to calculate, we should know how to calculate the cofactor, then we will make one matrix of that cofactor, then take transpose, that is the adjoint, divided by determinant, that is the inverse of this matrix. Okay. So one more question is that here, this is easy. A is matrix like 1 2 5 7. We have to find the inverse of this matrix. These all questions have been asked in the gate exam. So I just some time before I told you how to calculate the inverse of 2 cross 2 matrix. So inverse of this matrix will be 1 by determinant. Determinant will be 7 into 1, that is 7, minus 5 into 2, that's 10, and adjoint will be, just change this elements and change the sign of these elements. Okay, so that is 1 by minus 3, 7, minus 2, minus 5, 1. Taking minus 3, 1 by minus 3, that will be 7 minus 7 by 3, 2 by 3, 5 by 3, 1 by 3. But this one will be, this will be inverse for this matrix. Okay, and one more question is that One more question is that if any we have two matrices here, that is J of J is any matrix that is equal to 3, 2, 1, 2, 4, 2, 1, 2, 6, and one more matrix that is K matrix is given as 1, 2, minus. It has been said that find this matrix K transpose JK matrix. This has been asked. We have to find this matrix. Okay. So first to take the transpose of K matrix, that will be simply 1, 2, minus 1. Okay. And now take in this order, that is K transpose JK. K matrix K transpose is 1, 2, minus 1. J matrix is 3, 2, 1, 2, 4, 2, 1, 2, 6. Okay. And K matrix is 1, 2, minus 1. Just write the order here. There are 1 cross 3, 3 cross 3, 3 cross 1. Okay. So the number of columns in this case and number of rows in this are same. So for these two, multiplication is possible, and same is for this. That is, number of columns in this is 3 and here rows are 3. So multiplication is possible. That we have to check that first. Only then we can multiply. So multiply here this row to this column. So we will get here matrix that is 1 cross 3. That's same matrix, like in the same order. 1 into 3, that is 3. 2 into 2, that's 4, minus 1. Second will be 2 plus 4 into 2, 8, minus 2. And third will be 1 plus 4 minus 6. Okay. And this will remain as it is. Here it will be 6, 8, and this one will be minus 1. Okay. 1, 2, minus 6, 8 into 2, that is 16, plus 1, that's 23. Okay. So 23 is the answer for this. This question was also asked in the GATE for 2 marks. Okay. Now one more question is that wait, just wrap this. Question is that A is a matrix that is complex. There are complex elements in this. 3 plus 2 iota, 3 plus 2 iota, iota, minus iota, 3 minus 2 iota. Okay. So it's a 2 cross 2 matrix. We know the shortcut for this. That will be A inverse will be 1 by determinant of a matrix to adjoint of a matrix. We know how to calculate determinant. That is just multiply these two. 3 plus 2 iota into 3 minus 2 iota minus iota into iota, and just change these two elements, that leading diagonal element 3 plus 2 iota, change the sign, that minus iota plus. Okay. So this is like A plus B into A minus B, that is A square minus B square, that is 3 square minus 2 whole square. Iota into iota gives us, so this will become plus, iota into iota gives us minus 1. Okay. This will remain as it is, 2 iota minus iota plus iota, 3 plus 2 iota. Okay. Just solve this. That's 3 square, that's 9, minus 2 2s are 4, and iota square give minus, so it will become plus 4 and minus 1. 3 minus 2 iota minus iota plus iota 3 plus 2 iota. Okay, so it will become 1 by 9 plus, that is 13, that will be 12. 3 minus 2 iota minus iota plus iota 3 plus 2 iota. Okay, this is the inverse for this matrix. This were also asked in the GATE in this question. So questions asked in the competitive exams are easy. These are not that much tough. We should do the basic how to calculate, and these are lengthy also. Questions are designed from the time point of view. You can solve if the question having there are 100 questions for, and 100 minutes are given to solve those questions. Some of the questions may take 2 to 3 minutes to solve, but some you can solve in just seconds, 2 to 3 seconds. If you know the answer, just take that question. Okay, so don't worry about the time, you can solve these questions. So let's take one more question, that is, if A is a matrix 1 5 6 2 and B is one more matrix 3 7 8 4, it has been asked, we have to find A B trans. This thing we have to calculate. Okay, so first we will find what is the B transpose. B transpose will be just change the rows into column 3 8 7 4, and now AB transpose will be A matrix 1 5 6 2, and B transpose is 3 8 7 4. Now just you know how to multiply this row to this column. Okay, that is 3, 1 into 3 is 3, 5 into 7 is 35, plus 8 plus 40, no sorry 20, 5 into 4 20, and 6 into 3 18, 14. Okay, 6 into 8 48, and 8. Just add these elements, we get the answer. That's 38, 28, 2, that's 30, 32, and this is 56. This is our answer. Okay, we will take one last question now regarding this case. Question is that, first let me wrap this. Question is saying that there are 4 options in the question. This question was asked in the GATE 2018. Like 4 options were A was 2 5 1 3, B matrices, but B option was 3 2 2 3, and C matrix 2 4 3 6, D matrix 4 3 6 2. GATE 2018 2 mark. It has been asked, we have to find which of the following is a singular matrix. We know the basic definition for a singular matrix is that determinant of a matrix should equal to 0. So just calculate from this for which of the following is a determinant is 0. That is our answer. So 3 into 2 6 minus 5, so determinant is not 0, so it is not singular. 3 into 3 9 minus 4, count our answer. 6 into 14 minus, sorry, 6 into 2 12 minus 4 into 3 12. Okay, so determinant is 0. 6 into 2 minus 3 into 4, 12 minus 12, 0. Let's check this one also. 4 into 8 minus 6 into 3, 18. So our answer is, you see, it took hardly 30 seconds to solve this question, and it is asked for 2 marks. Okay, and before closing this lecture, I will in the last lecture I have asked you one question, that was if multiplication of 2 matrix A B we are getting as a null matrix. Question was this: is it necessary that any of them should be equal to 0, that is, if A should be equal to 0, or B should have been as null matrix, or both has to be null matrix, that is both A and B should have been null matrix? This was the question. So we will I will give answer to this question by taking an example. Like if A is a matrix for me as a unit matrix, 1 1 1, this is not a null matrix, so this one goes. And B is also one matrix, that is 1 minus 1 minus 1 1. Okay, so neither A is a null matrix nor B is null matrix. Now we'll calculate the multiply, that is multiply of these two matrices, multiplication. 1 1 1 and 1 is 1 minus 1 minus 1 1. So this will be 1 minus 1 minus 1 plus 1 minus 1 plus 1 1 minus 1. Okay, so we are getting 0 0 0 0. That means A and A multiply B is as a null matrix we are getting after. So in this, neither A was a null matrix nor B was null matrix, so we are getting as a multiply as a null matrix. So it is unnecessary that if